Hi, in this video we are going to go over the solution of the problem H76, middle of a linked list. So for solving that problem, let's start first with defining a linked list. So for doing that, I'm going to have a class node, and I go and define init as self and data. So self.data equals data, and self.next be none by default. And then I should define the nodes. So I say node A is node with a value 10, and node B equals node with a value, for example, 12, and so on. So I have node A to node F, and then I should say I need what is the connection between these nodes. I say node A is connected to node B, and node B is connected to node C, and so on for the other connections. So this is our linked list, and if you want to see how that looks like, that should look like something like this. So I have node A, B, C, D, E, F, and F is going to none, and value of that is 10, 12, 8, 2, 5, 7. And what we are interested is to find this 2 here, which is in the middle of the linked list. So for solving that, so we are going to write a function. So let's start. We say define a function. We call it middle of a node, and the input is the head. Here head is actually node A, and I'm going to solve this problem by using 2 pointers. So I have imagine that we have 2 runners, and here is a starting point and this is a finish line. So I have a runner who is very slow, and I have a runner who is very fast. So the slow runner is the fast runner speed is 2 times the slow runner. So when this runner comes to this milestone, so the other one is here, 2 steps forward. When slow comes to 2, it says 1, 2. It goes 2 forward. So 1 forward, fast goes 2 forward, 1, 2. So at this moment, fast reached the end to the finish line, while slow is at the middle because the speed was the half. So that is the intuition behind the solution of this problem. So now let's start these variables, define these variables. So we say slow equals fast equals head. Both of them are at the beginning right now. Now I say while fast and fast dot next are not noun, so we say slow equals slow dot next. I go forward for the variable slow, and for fast I say fast equals fast dot next dot next. I go 2 steps forward, and I return a slow dot data. I care about this number 2 here. I want to return that. So now let's print output of that. So we say middle of the linked list, and it's going to be, what was my function? My function called middle node, and head node is A. So let's run that. Okay, we can get we have to have a correct init function here, and when we run that, we get the value 2. And as you see, for this example, we had 1, 2, 3, 4, 5, 6. So we have 6 nodes, and this is an even number. So how about having an odd number? because for that one we might have fast might end up in a different location. So let's try that one. So imagine that I have a shorter linked list, something like this. So I don't have the F. Let's comment that out. So I have up to E, and now let's see what happens to a slow and fast. So for example, this is a slow and this is fast. So a slow comes one step forward, fast goes 1, 2. So a slow go 1 forward, fast go 1, 2. So if I go one step slow forward again, so fast cannot go 2 more. So I'm saying if I go a slow 1 more forward, I have to go fast 2. So I have to go 1 here and then beyond the none. That is not possible. So as the result, so we should stop here. So whenever fast is fast.next, so this one is none also, we have to stop. That is the reason in this while loop statement we should have both fast and fast.next not as as none. So whenever fast hits none or fast.next hits none, so that's where we stop. So in that case we can handle in a situation that we have an odd number of nodes in the linked list. So let's run this one now, and you can see, okay, we get the middle of the linked list as 8. Okay, so in this way we can define a linked list, and we can see what is the middle value of the middle node and the value for that. So for the space complexity of that, so a space complexity of this problem is of order big of 1, because we just had a one variable, so we that is stored fast, and we just replace that. We are not making a vector or something like that. And the time complexity is order of n, and because we are going to go over all of the nodes, so the fast is going to go 1, 1, 1, 1, and a slow half of that. So in the worst case scenario, it's always less than n, and for that reason, it's actually we are not going to go over all of that. We are actually going over half of it, but half of n, because n is very big, so we just call it O of n. So that is pretty much the solution of the problem 876. So we defined the class, we showed how we can define a node, and we showed that by having 2 pointers, slow and fast, we can find the middle of a linked list, and we showed that what is the case for an even number, having even number of nodes or odd number of nodes, and we showed that in the while loop statement we handled that situation. And then we saw the time and space complexities. Okay, thank you so much for watching this video.